All right, let's jump right in. Today, we're going to break down a huge concept, one that powers some of the biggest apps you use every single day. We're going to build our very first user service using Go, all based on the microservice architecture.
And just so you know, all this great material comes from Mira Developer by Mira World. Seriously, if you're looking to become a professional backend developer, this is a concept you absolutely have to understand inside and out.
So here's the plan. We're going to start with the big picture problem, then we'll introduce the tools we need to solve it. After that, we'll get our hands dirty with a real practical example, building everything from scratch. And at the very end, we'll connect all the dots. Sound good? Let's do this.
Okay, so first things first, why do we even need to talk about architectures like microservices in the first place? Well, it all boils down to one massive challenge: scale.
I mean, really think about it for a second. The system that runs Netflix or powers Amazon isn't just one big piece of software. It can't be. These things have to handle millions of people all at once, they need to be updated constantly, and they can basically never go down. So how on earth do they manage all that complexity? That's the big question we're going to answer today.
A huge part of the answer lies in the tools they use, and one programming language that has absolutely exploded in popularity for this kind of work is Go. So, what's the deal with Go?
You know, I love this quote from Go's own documentation because it just nails what makes Go so special. It kind of captures the magic, right? You get all the safety and the raw, blazing speed of a language like C++, but when you're actually writing the code, it feels clean, simple, almost like you're just scripting in Python. It's the best of both worlds.
These are really the core ideas behind Go's design. It's all about being clean and simple, so the code you write is easy to read and gets right to the point. It's also incredibly fast and efficient, but its real superpower, it's concurrency. Go was literally designed from the ground up to make it easy for your programs to do lots of things at the same time. And that is absolutely critical for the kind of networked apps we're talking about today.
Okay, so we've got our tool, Go. Now let's look at the architectural blueprint that it's so perfect for building, the microservice pattern.
The big idea here is actually pretty simple, but it's incredibly powerful. Instead of building one giant application where everything is all tangled up together, we call that a monolith, you build a bunch of small, independent services that all work together. Think of it like building with Legos. Each one does one specific thing and does it really, really well. To make this more real, imagine an online store. Instead of one huge program trying to manage everything, you'd have a user service that just handles logins and profiles. You'd have a product service for the catalog, a payment service for handling transactions. You get the idea. They're all completely separate little applications that talk to each other over the network using something called APIs. And you might be thinking, wow, that sounds kind of complicated. But trust me, the payoff is huge. It's way easier to fix or update one small service than it is to mess with a giant application. If your product catalog suddenly gets tons of traffic during a sale, you can scale up just that service without touching anything else. Plus, different teams can work on different services all at the same time, which makes development so much faster.
All right, enough theory. We have the language Go, and we have the pattern microservices. Let's put them together and actually build something. Let's get our hands dirty and create a simple, practical user service right now.
We're going to follow 4 really clear steps. First, we'll set up our main project file. Then, we'll define what our user data actually looks like. After that, we'll create a simple list in memory to act as a fake database for now. And finally, we'll wire up the URLs so people can actually interact with our service.
First up, we have to decide what a user even looks like in our system, right? For us, a user is pretty simple. They'll have an ID number and a name. In Go, we use a struct to create this kind of blueprint. And those little notes you see in backticks, those are just JSON tags. They're hints that tell our service how to format this data when we send it across the internet.
Okay, so our blueprint for a user is ready. Now for the really fun part, building the heart of our service. We're going to create the API endpoints. Think of these as the front doors that other applications will use to come and talk to our user service.
Let's start with the most basic function you can imagine. We need a way for someone to ask for a list of all the users in our system. So we'll create an endpoint at the URL/users that does exactly that.
And if we were to actually call that endpoint, this is exactly what our service would send back. Just a clean, simple, structured list with all of our users. In this case, Alice and Bob. It's predictable, it's effective, it just works.
But, getting everyone isn't always what you want. What if you just need one specific person? For that, we'll create another endpoint that can take a parameter. By adding that $ID equals 1 to the URL, we're basically telling our service, hey, I don't want everyone, I only want the user with ID number 1.
And yeah, just like you'd expect, the service looks up that ID and sends back only the data for that one single user. This is a super fundamental pattern in API design, right? The ability to get a whole collection versus fetching just a single item.
And finally, a service that can only read data is kind of boring, isn't it? We need to be able to add new data. So we'll create what's called a post endpoint at /createUser. Another application can send new user information to this URL, and our service will take it and add it to our list.
So we did it. We just built the tiny but fully functional microservice. Let's just take a step back and connect all the dots. Why was Go such a perfect choice for this job? And this is the absolute key takeaway from all of this. It is not a coincidence that you see Go and microservices together all the time. The best features of the language directly support and even amplify the benefits of this entire architectural pattern. They're a perfect match.
Let's break it down. Remember we said Go's syntax is clean and simple? Well, that leads directly to faster development, which is a major reason to use microservices. We said Go is compiled and efficient, right? That gives us the super high performance a service needs when it's getting called thousands of times a second. And most importantly, Go's built-in superpower, concurrency, is the perfect foundation for building services that can easily scale up to handle massive amounts of traffic. See how it all fits?
So look at what we just did. We went from a really high-level problem all the way to a working solution. You've just seen the core principles of how modern, massive, scalable applications are built, using a powerful language and a really flexible architecture. The building blocks themselves are pretty simple, but what you can create with them is absolutely limitless. So the only question left is, what are you going to build next? If you enjoyed this, be sure to drop a comment, hit that like button, and subscribe for more great content. Thanks for watching.